Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan Syafuddin Muhammad Ruslan. So our today topic is about Genting Tunnel, and this program is DN230155, and my lecturer is IR Muhammad Faiz bin Abdul Latif. This subject name is Infrastructure dan Kemudahan Rail. So without wasting the time, I will continue this presentation to the introduction part. So we continue to the introduction part. For the location, is located between Bentong, Pahang and Gombak, Selangor. Next, the project name is Genting Tunnel, which is part of the East Coast Rail Link (ECRL) project. This tunnel length is 16.39 km, so it will be the long tunnel in railway transportation service Malaysia. By Genting Tunnel, we can reduce the travel time for transportation service, which is from 3 hours to 90 minutes. For construction status, this tunnel is still under construction and is part of phase 1 of the ECRL alignment. So for the purpose of this tunnel is we want to link the east coast where Kelantan, Terengganu, Pahang to the Klang Valley. So that's all for introduction parts. Now, let's talk about one of the most modern and advanced tunneling methods, which is the tunnel boring machine or TBM. TBMs are large cylindrical machines used to excavate the tunnels with a high degree of precision. While the slide mentions that TBMs are ideal for medium to soft rock and minimize the surface disruptions. Let me take a moment to explain how the tunnel actually works and why it is important in tunneling projects. Inside the front of the TBM is a massive rotating cutter head which cranes through soil or rock. As it advances forwards, the machine also removes the excavate materials, so it is a mark and through a screw conveyor or bed system. This keeps the tunnel face stable and clean. As the machine progresses, it installs the precast concrete segments to line the tunnel, providing immediate structural support. This makes the method very safe and efficient, especially in urban areas or beneath sensitive structures where ground movement must be minimized. And there are different types of TBMs, which is pressure balance, EPB, and slurry TBMs is designed to handle specific ground conditions. For example, in soft soil with water, and a slurry TBM used to pressurize the fluid to maintain the phase stability and preventing the ground collapse. So the next method. So this method is traditionally used for hard rock tunneling, especially in mountainous or rural areas where geological conditions are too tough for soft grounds like TBMs. So the process begins with the drilling multiple small holes into the tunnel face, typically in a specific pattern depending on the rock type and the size of the tunnel. These holes are then filled with carefully measured explosive charges. Once detonated, the blast fractures the rock into smaller pieces, and which is then cleared away using the excavators, loaders, or conveyor belts. After mud removal, the exposed rock surface is often to stabilizing using the rock bolts, or wire mesh, or shotcrete. Although this method sounds aggressive, it's actually high controlled. In modern practice, precision blasting techniques are used to limit the vibration and reduce the noise while minimizing the surface impact. That makes it surprisingly suitable even in environmentally or structurally sensitive areas. As long as proper safety and environment controls are in place. One major advantage of drills and blast method is flexibility. It can be adapted to different tunnel shapes and size, and it doesn't require the high start-up cost for a tunnel boring machines. And however, the trade-off is lower progress compared to mechanized methods, especially in long-distance tunneling. The advantage of this tunnel. First, it reduced travel time is one of the most direct benefits by creating straight underground routes, especially through mountains or beneath cities. So the tunnel eliminate the need for the detour slopes or shaped curves. Secondly, tunnel projects often act as a boost to the regional economy. During construction, they create jobs in engineering, construction, logistics, and material supply. Another major benefit is the minimization of surface disruptions. Unlike road widening or elevated projects, tunneling occurs the underground, which will help preserve existing roads, buildings, and natural landscapes. Finally, tunnels contribute to the long-term national infrastructure developments. Tough and passive upfront, they are built for a decade of low maintenance. So disadvantages part. Firstly, the construction cost is extremely high, especially when using advanced machines like TBMs. This include not only the cost of the machine itself, but also setup, transport, and specialized labor. And secondly, tunneling projects often involve an extended timeline. Unlike surface construction, tunneling requires detailed geological surveys, careful excavation, and constant monitoring, which can slow down the progress. Next, we face the significant geotechnical risks. Unexpected ground conditions like water, egress, stable rock, or fault zones can cause the delay safety concerns or design change during the constructions. Lastly, many tunneling projects, especially in developing countries, still rely on the foreign technology and expertise. This creates dependency and can increase the cost, especially when the repairs, parts, or skilled operators are needed from the overseas. So while tunnels are crucial for modern infrastructure, this challenge must be carefully managed and for a successful project outcome. And the last part of this presentation, which is the reference, and this part I will show you about the Genting tunnel progressions or image that we can see the machinery items and the surface of the tunnel of Genting tunnels. So that's all from me. Thank you very much.